and volcanoes occur in conjunction with the release of energy or matter. In the case of earthquakes, most earthquakes occur at plate boundaries. I will say, however, that volcanoes such as Yellowstone, which are not on a plate boundary, do experience earthquakes, and that's a function of the tension that exists in the caldera and the buildup of matter within that caldera. That nature in the tension must get released, and it does so with the eruption of a volcano. But that tension, whether it's in the caldera and near the caldera and adjacent rock structures or along a plate boundary, is going to have to get released at some point in time, and the magnitude of release is equivalent to the amount of tension there is in that rock structure. In the case of earthquakes occurring along plate boundaries, what happens is that rocks get stuck in place along that plate boundary. And when they get stuck in place, they are adhered to, or they are locked together for as long as the rock can withstand the push, the pull, or the ripping movement that plate wants to undertake. At the moment that the rock can no longer withstand the tension from the plates against each other, then the earth will move. The plates will slip past each other or away from each other as a result, and they will release the volume of energy which was held at that point where the earthquake took place. That location is the weakest point in the rock structure, the one location where the structure could no longer withstand all of the energy being held. Think of it like the old game Red Rover, where you have a line of individuals on either side of the playing field, and the opposite team has to make a choice on who they're going to call across and try to break the line of people holding hands. Most often, who is called is anticipated to be the weakest member of the team on the other side. That member has to make a decision on who to run through, which people have the weakest link between their arms. The nature of the earthquake works the same way. The entire line, the entire plate boundary absorbs tension and over a long period of time, but the place where the rock is the weakest is where it's going to break. So we end up considering that as a stick and slip scenario, where the rocks stick for a period of time and then they suddenly slip in a movement in the direction that the plate tension is built up in. That location where the sticking takes place and the release takes place is the focus. The focus is within the Earth's surface along the plate boundary. It is not at the surface. When we talk about what's happening at the surface, what we're talking about is where the epicenter is. The epicenter is the place right above the focus where the Earth begins to shake. So that's what this looks like. So we've got our plate boundary here, our fault line. In this case, our fault line is coming in at an angle. And somewhere along that fault line in this three-dimensional plane, so I want you to imagine that this whole unit, the fault line, goes back in this direction and then forward in this direction. So in this location along this three-dimensional surface, a piece of rock can no longer hold the weight of the mass and the force being exerted upon it, and it releases at this location. Energy moves along the easiest route, so it's going to move up the fault and down the fault, as well as across through the different rock structures in 3 dimensions. So 360 degrees, we're going to get vibrational S and P waves, surface and through waves occurring. It's at the point straight above that foci that the epicenter occurs, right here. So this is what you hear on the news and the radio, is the epicenter was at a geographic location on the surface of the earth, but that's not where the earthquake took place. The earthquake took place directly below it. So at these plate boundaries, volcanoes also exist to one degree or another. The highest correlation or relationship of volcanoes to earthquakes, and consequently those fault zones and plate boundaries that they occur on, are at subduction zones, where we're physically having rock pushed into the surface of the earth. The greatest volume of push and the greatest degree angle of push will result in the highest volume of volcanoes and volcanic eruptions. The largest volume of active volcanoes that we have on the surface of the earth is in the Pacific Ring of Fire. Now remember, we said the pole is happening at the zipper in the Mid-Atlantic Ridge, and then opposite that is where we've got most of the subduction taking place. So the earth is sort of being pushed together on the far eastern edge of the Pacific Plate, and consequently that's where we're going to get the greatest volume of active volcanoes currently. The second most strongly associated location of volcanoes is going to occur at rifting zones, where the rock is being pulled apart. So we've got a good number of volcanoes along the Mid-Atlantic Ridge and other locations. Now, we don't think of those volcanoes very often, and that volcanic activity very often, because it's submarine. It doesn't affect humans on a day-to-day basis. It can, though, occur and impact humans when the rock structure breaches the surface of the water, which it did with Surtsey Island in Iceland between 1962 and 1967. It created 3 islands. The only one of them, Surtsey, has survived wave erosion since then. So volcanoes are also correlated with transform faults, but to a lesser degree. And that's what we see in California. So when you look at a map of California, most of the transform faults, where the plates are moving tangential to each other, the volcanoes are off from the earthquake zones where the faulting is. They're off to one side. They're not directly above like they are with rifting zones. They're not marginally adjacent to like they are with subduction zones. So they're a little farther off. There's less tension, there's less pressure into the asthenosphere, and there is less emergence from a thinning zone as there was with rifting. So these volcanoes are going to be fewer in number and less intense in volcanic activity. So here's the correlations that we're talking about. So we see this significant subduction zone through here between the Nazca Plate in South America and the Caribbean Plate, and we've got a large correlation of volcanoes here. We've got a subduction plate through here towards Oregon and Washington, so we get an occurrence from Northern California through to Southern British Columbia volcanoes. But the transform faults in Southern California from through to the Baja Peninsula are quite few in number as a result. Our largest occurrence of volcanoes are right here along this subduction zone, which comes from Kamchatka all the way down through Japan. We've got a significant number of active volcanoes, but enormously also expulsive volcanoes through this area as well. So Southeast Asia is incredibly significant. Our rift, and then we've got a subduction zone that transects between the African plate and the Eurasian plate. So we're looking at areas that occur through the Hindu Kush, across into Turkey, and then through Greece, and then into Italy. We have a series of volcanoes. Our rifting zones, we've got our African Rift Valley through here, and then we've got this active zone that's occurring up here, and then a smaller active zone sort of in the middle central part of the Mid-Atlantic Ridge. Those are our big ones. We've got isolated zones like the Caribbean, like down here in the Southern Ocean, that occur as well.